Hello, in this session we'll see this question on random variable. It says the distribution function of a random variable x is given by f of x is equal to 0 for x less than 0, x by 2 for less than 1. These are the values, and we have to compute x less than 3, x equal to 1, x greater than 1 by 2, and for an interval this, right? So let's see something, let's observe something, and then we'll move to the solution. This is our distribution function, and obviously we can see it is changing at the some points like 1, 2, 3 and so on, and it remains so, like it remains 2 by 3 for certain value, 111 by 12 for certain, and then 1 and so on, like that. So somewhere this is a discrete random variable, and for x less than 0 the distribution is 0, which means we don't have any random variable which is less than 0. We don't have any random variable which is less than 0. And up to 1, this is going to be x by 2, which is kind of continuous, which is continuous. It is increasing continuously, and that is why it is given as x by 2. Other than that, from 1 to 2, it is sharp 2 by 3, which means it is discrete again. Right at x equal to 1, it attained some value, and after that from 1 to 2 it didn't increase. So that means there is no random variable between 1 and 2, right? And similarly, after right at x equal to 2, this became 11 by 12 from 2 by 3, which means there was a density at x is equal to 2, and that is why 2 by 3 became 11 by 12. And again it remained same from 2 to 3, and suddenly at 3 it became 1. That means the density at, like, right, what can be the distribution function at x equal to 3? It can be this all value of distribution for less than 3 plus, if I'm saying this value is nothing but this value plus probability of x is equal to 3, right? Then there is nothing wrong in saying that. Fine. So that means this is the value we have got till the distribution till x is less than 3, and right at x equal to 3 it becomes abruptly 1, which means the density at x equal to 3 made this sudden increase from 11 by 12 to 1. Similarly, this happened up to 2, it was 2 by 3, and then when we add density at x equal to 2, we'll get this value, right? Right? There is no value between x equal to 1 to x equal to 2, no value between x equal to 2 and x equal to 3, right? So such observation we can definitely make. So let's start with the first one. The first one says we have to find the probability up to x is less than 3. So it is very simple. Like I said, up to x equal to 3, the distribution is 11 by 12, and right at x equal to 3 it becomes 1. So up to, like, x less than 3, it is going to be 11 by 12. So that is the answer. But still you can write it in the manner, this will be nothing but f of, like we had an interval from a x b, so we wrote it to be equal to f of b minus f of a. We wrote so, right? So from this you can relate that the upper limit is this is equal to b, less than equal to b, but this is less than 3, and there is no lower limit. If there is no lower limit, it means it can go up to the lowest random variable possible, and the lowest random variable possible is x equal to 0. We have seen this, right? So this means we'll have to find a limit of 3 minus 1, let's say 1 by n, where n tends to infinity. So that means we have to be just right before x is equal to 3, and this will be nothing but 11 by 12, because if it would have been x less than equal to 3, then we could have made directly f of 3, which was 1, right? So that is not what they're asking. They're asking right before 3, so it is going to be 11 by 12. Had it been x less than equal to 3, the answer would have been 1. Second part is x equal to 1. So you want a density right at one point, which is x equal to 1. Now if we check the graph, or if we check the function, it is x by 2 up to x less than 1, and then suddenly this becomes 2 by 3. Can you tell me what will be the value if f for this function? What will be the value? What will be the value for this function if x is tending to x tends to 1, or right, it will be approaching from the negative end, so 1 minus. If this function is approaching 1, this value, this limit is going to be nothing but 1 by 2. So the distribution right before, like very right before x equal to 1, it is 1 by 2, and at x equal to 1, it is 2 by 3. That means there was a sudden density function at x is equal to 1, right? There was a density function at x equal to 1. This is behaving discretely, x equal to 1, 2, 3, and so on. So that means we can find this value by giving f of 1 minus f of 1 minus 1 by n, where n tends to infinity. So that is like right before 1. So at 1, this is 2 by 3, and right before 1, it is 1 by 2. So this gives it to be 1 by 6, right? X is equal to 1. Next one is probability for x greater than 1 by 2. Now for probability function, we know one thing: for whatever range it is defined, the overall sum or the overall integral is going to give you 1, right? So if you want x greater than 1 by 2, so this x greater than 1 by 2 can go up to any value, but definitely we can do one thing. We can write it as 1 minus probability of x less than equal to 1 by 2. Why have we written x less than equal to? Because this is including greater than, that means it is excluding x equal to 1 by 2. So I'm not writing x less than 1 by 2, I'm writing x less than equal to 1 by 2. Now let's get back to the function x less than equal to 1 by 2. So x less than equal to 1 by 2 is in this range, and in this range this value is x by 2, right? So this becomes 1 minus f of 1 by 2, and that 1 by 2 is x by 2. This becomes 1 minus 1 by 2 into 1 by 2, which is 1 by 4, and this value becomes 3 by 4. We can see there is no lower limit. If there is no lower limit, we can directly put the distribution value for that value. This case it is x equal to less than equal to 1 by 2, so we are putting 1 by 2. But in the previous case it was x less than 3. It was not x equal to 3. Had it been x equal to 3, we could have written f of 3, right? So there is a difference. Next is probability for the interval greater than 2 and less than equal to 4. So this is possible. So this is very simple. Directly we can write f of 4 minus f of 2, right? We know the direct formula for this. This is included, this is not included. F of 4. So what is f of 4? For any value x greater than equal to 3, f of x is 1, and f of 2 is 11 by 12. This is f less than 2. So we have to count f of 2. F of t is 11 by 12. So we'll write minus 11 by 12, which is 1 by 2. Thank you.